Good day everybody. Today we will see a few examples of usage of MATLAB in statistic and economy, and also in signal and image processing. Of course, the examples that today you will see are pretty preliminary, and in order to see more examples, it's highly recommended that you go and visit the MathWorks File Exchange website. Now let's open our MATLAB. Keep it in our mind that by end of this mock you have the enough knowledge in order to read any code which is provided to you. Remember, if there is any command and you are not familiar with that one, you can always go and look at the help of MATLAB. For instance, assume that you have seen a command called sum and you don't know what is the task of that sum. So what we do, we write help sum and we press enter, and it tells you a very good information that how the sum works, and it even provides you a few examples which you can use it. Now as I said, let's do a few tasks. The first task that we want to do is this. We open our M file and we define, let's say, a variable called grades. It's a vector and it contains, let's say, grades of students in a class. Let's say 100, 91, 92, 85, 40, 77, 92, 91, and 94. Let's have 92 once more. Now, if I run this code, let's call it test 11, we will see that we have the grades, and these are the numbers of the grades. Assume I want to calculate the mean. So what I will do, I can define, let's say, the AVE, which is average, is the mean of grades. So the function mean is calculating the mean of the grades that we have, and it is 85. So if I want to find out, for instance, the median of the variables that I have, I can say MD, representing my median, let's say, and I'm using the for median in order to see what is the median of the grades. And in order to see it, it says that the median is 91.5. Now, in order to find out how number 91.5 has been calculated, it's nice to sort grades, and it sorts it, as you can see, in the ascending order from the smaller value to the higher value. The mid value, as you can see, are 91 and 92, because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. Assume if I'm adding one more value, like let's say 53, and I run the program, the number 91 here is the median, the middle value. But as we saw previously, if the total number is even, then the median will be the average of the two values that we have in here, and the average is 82.45. So if you want to find, let's say, I don't need the sorting, to find out what is the most frequent variable that we have, we can use mode. Let's call it F is equal to mode of grades, and when I run it, it says that number 92 is the mode, because as we can see, number 92 has been repeated 3 times. Now let's see, if you have this data in your hand, of course it's a very simple data, but assume that you want to see what is the standard deviation of your grade, what is the variance of your grade. For this purpose, what we can do is we can define, for instance, a standard deviation as to be STD of grades. And when we run it, we see that the standard deviation is 18.88. Or we can have the variance by writing var of grades, and we run it, and it says that the variance is 356.7. Of course, if we calculate the S squared, the standard deviation square, we will get the variance already in our hand. Now, so You see, we can use easily standard deviation, variance, mean, median, mode, and we can do it for a vector. If we have a matrix in our hand, let's see what will happen. Assume I have a matrix of 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Now here I have a matrix. As you can see, it is a 3 by 5 matrix. If I am using the comment mean, let's see what is the output. The output will be, as you can see, a vector with 5 values. MATLAB does all the tasks on a column. It's column-based operation. In other words, if you have a matrix, as you see here, when you are applying a comment like mean, it calculates the mean of a column and put it in here. Mean of the next column and put it in here. Mean of the other one and put it in here. If you want to find the mean of a row, the mean of each row, you have to calculate the average of the grade transpose. Then it means that all these 5 will be, let me even put a transpose in here, and then you will see what is happening. Here, as you may see, I have a 5 by 3 matrix, so I can I have to clear my variables, and I don't need to have the transpose in here. So you will see that what happens, I have the average of these 5 numbers in here, or you don't need to do it, and I put the prime in here, and you see I have the average of the first row, average of the second row, and so on. Now let's get back to our original question, which we have a 3 by 5 matrix, and when we are writing the mean, I am getting the mean of each of these columns. But assume I want to find the mean of the whole matrix. In order to do that, I have to find the mean twice. In other words, I have to write it as mean of grades, and if I run it, it tells me that this is the total mean of all the numbers and grades that you have. In case of mean, we can have mean 2 comment, which means that the parameter is a 2-dimensional matrix, and I have to do mean twice, and you will see that we will get the same number. Now let's see what will happen if I want to apply median. If I do, it tells me that what is the median of each column. Similarly, in order to find the whole median, some of the comments are not simply by having median, but put 2 here. As you can see, if I write median 2, it tells me that there is an error. So what I have to do, I have to write median again twice if I want to see it, and it tells me that what is the median of medians. Now I want you to see something in here, because this observation is pretty important. The median of each of the columns have been mentioned in here: 91, 92, 92, 85, and 92. Now if I want to apply median again for med2, it means that I have to sort this one, and then I have to find the middle value, which is 92 in our case. Now if I want to do the mode, you will see that again it's column-wise operation. If you write mode 2, you will not be able to get an answer. In order to see the most frequent element of all, then you have to do the mode twice. Now regarding to the standard deviation, this is a standard deviation of each of the columns. We can write std2, and std2 will give me what is the total variance of the matrix. You have to be careful here, because let's see what will happen if I am writing std twice. you see that we are getting different answers. The reason behind it is, let's have even this one in here so we can easily observe as 0. So when I use std_do, it finds the standard deviation among all the data. If I use only std, what is happening? It tells me that what is the standard deviation within each column. And when I write std, I find the standard deviation among these standard deviation. That's why that the results are not corresponding to each other. Now, regarding to the variance, you can calculate the standard deviation, square it, or we can simply use the var, which gives us the variance of each of the columns. Or if you want to find the whole variance, you have to go calculate the standard deviation by std2 and square it. As you can see, var2 is not giving us any results. Now, so this was a simple example of how you can calculate some very basic statistical parameters through MATLAB. Let's open another M file and let's see some examples of signal processing and image processing. In these examples that we want to do, we will read an image and we will manipulate this image a little bit. For doing this, we are putting an image in the folder that we want. Now, I have my photo in a folder. I am copying it, and here in the current folder that I can come and paste it. So I have an image called Obelix underscore 128.png. Now, in order to read an image, let's call it X is my image. X is equal to, let's CLC clear all. So now we have the clear all here. Then let's go to the next line, and we are defining a variable X to be the image that we want to read. And in order to read an image, we are using a command called imread. And here you can see the way that we are using the syntax, the name of the image, whatever your image is. Here is Obelix 128.png. You can use any type of postfix. And when we run it, you see that X is a variable which has 3 dimensions, 128 by 128 and by 3. And these 3 represent its a color image, RGB. The type is, the class is on-site integer 8-bit, which means this minimum value is 0, the maximum value is 255. In order to if you want to see this image, we are using the command called imshow, and if you run it, you will see that it will open a window, a figure, and inside it shows the color image of Obelix that we have. Now, you can convert this image into grayscale. Y is equal to RGB to gray. X, and if we run it, and if you look at the variables, now variable Y has only 2 dimensions because it has only the gray tones. Now we can look at the image of Y. We can write figure and look at Y, and we run it. So the first figure is our image in color, and the second figure is our image in gray tone. We can look at some portion of, let's comment this one. We can look at some portion of Y. We know that Y has 128 by 128. So let's look at 50 to let's say 100, and 45 till 105. And when we run it, you will see that here we see some portion of our image. You can manipulate many things. Image, there are lots of comments. As I said at the beginning of today's lecture, you can always go to File Exchange at MathWorks and look at the other applications on image processing, signal processing. If there is any comments that you don't know how to use it, you can always go to the help of MATLAB. For instance, assume that you know a syntax for square root is sqrt, so you can always write help and sqrt. and it tells you how to use it. If you don't know it, you can go to the help, product help of MATLAB, and this window will be open. Here you can write that, for example, square root. As you can see, it's that much strong that it tells you that the functions which you can use for doing the square root, and it gives you an examples which you can use and run it. If you have the Simulink toolbox, it also tells you that what are the syntax or the blocks that you have to use in order to calculate the square root. I hope that you enjoy this mock and it gives you the initial fundamental in order to start the long journey of using MATLAB in your research, and be seeing you in another mock. Have a nice time. See you.